Lesson 6-5, Operations with Radical Expressions. The properties used to simplify radical expressions involve square roots can be extended to radical expressions involving nth roots. So the product property of radicals says for any real number a and b and any integer where n is greater than 1, you can do the nth root of a times b is the same as the nth root of a times the nth root of b. So you're just really breaking it down into prime factorization. And it says if n is even and a and b is greater than 0, or if n is odd. Okay, so like for example, 12, the square root of 12 times the square root of 3 is the square root of 36, which can be written as 6. You could also break this down in other ways. You could just do this as the square root of 4 times the square root of 3 times the square root of 3. The square root of 3 is 3. The square root of 4 is 2. 2 times 3 is 6. So there's multiple ways of breaking these down. So the quotient property of radicals states that for any real numbers a and b cannot equal 0 and any integer greater than 1, if you have a fraction as the radicand, you can still separate the radicals in the numerator and denominator and simplify it. So the square root of x to the fourth divided by the square root of 25 can be rewritten this way, and then simplify it, which will give you x squared divided by 5. Or you can write it as 1/5 x squared. Properties of radicals and process of rationalizing the denominator can be used to write the radical expression in simplest form. A couple things to keep in mind when you're writing your answer in simplest form. These conditions must be followed for it to be in simplest radical form. The index n is as small as possible. The radicand contains no factors other than 1, and that are nth powers of an integer or a polynomial. The radicand contains no fractions, and no radicals appear in the denominator. And if it does appear in the denominator, you'll have to rationalize the denominator. So our first example, here I need to simplify each of these expressions. So here I need to find the cube root of negative 27. The cube root of negative 27 is negative 3. The cube root of a to the 6th is a squared. And then the cube root of b to the 14th. Now I can't take 14 divided by 3 to get a number like I did with 6 divided by 3. So what I can do here is I could need to have groups of 3. So I could have b to the, let's see, we could have b to the third times b to the third times b to the third. So that's 3, 6, 9. We need to get to 14. So let's see, if we did let's do 4. So b to the fourth, b to the fourth, and b to the fourth. Cube root of b to the fourth. And then we'd have b to the second. And these would all be the cube roots. So that means these 3 can, when I multiply that by itself 3 times, that gives me b to the fourth. And all I have left is the cube root of b squared. Now this index is smaller than this exponent is smaller than the index there, so that is okay for that. So this would be my final answer. Next, square 75 times x to the 12th times y to the 7th. If I break this apart as square root of 75, this can be the square root of 25 times the square root of 3. And then this is an even number, so that would give us x to the 6th. So let's simplify their numbers right now. So right now I would have 5 and then the square root of 3. square root of x to the 12th is x to the 6th on the outside. And then this one, I can have y to the 3rd, and then I would have one y left over. So my answer would be 5 times x to the 6th y cubed times the square root of 3y. Next, the cube root of -8 gives us -2. The cube root of x cubed is x. And then the cube root of y to the 7th, I can do 7 divided by 3, which will give me y squared with the cube root of, I'll have 1y left over inside. So this would be -2xy squared times the cube root of y cubed. Next one, break this down to the square root of 80. That one I can do the square root of 16 and the square root of 5. So the square root of 16 and the square root of 5. Then I can do the square root of a squared times the square root of a squared times the square root of a. There's my 5. And then I could do the square root of b to the 5th times the square root of b to the 5th. This is 4 times the square root of 5. These two make a squared times the square root of a. And these two equal b to the 5th. So my final answer would be 4a squared b to the 5th times the square root of 5a. There's my answer. Next, simplify these. So now these are the 4th root. So I have to think, what do I multiply it by itself 4 times to get that radicand? So right now, I can't do the 4th root of 4, so I'm going to keep that as the 4th root of 4. I can have x to the 5th divided by 4 would give me, I can do one group of 4, so that'd be x. And then all I would have left is the 4th root of x. So this one x represents 4 of them, plus the 1 gives me 5. So I just did the 4th root of x times the 4th root of x times the 4th root of x times the 4th root of x. These here form that x. And then I have 4th root of y to the 20th, which is y to the 5th. And I got that one because I had the 4th root of y to the 5th times the 4th root of y to the 5th times the 4th root of y to the 5th times the 4th root of y to the 5th. These four make that. So now we can write our answer. Our answer, everything on the outside would be x y to the 5th times the 4th root of 4x. Next, the square root of 60. So let's do 60 divided by, let's see, other perfect squares. 16, nope, 60 divided by, we did 60 divided by 4, that's 15. So this would be square root of 4, square root of 15. So we can have 2 square root of 15. And then we would have square root of a times the square root of a times the square root of a. These two form a. And then I have the square root of a. And then I have b to the 11th. So I could do the square root of b to the 11th and the square root of b to the 11th. These two would form b to the 11th. So my final answer would be 2a b to the 11th times the square root of 15a. Example 2, simplify the expressions with the quotient property. So all of these we're going to be dividing. So I need to find the cube root of 24. So cube numbers I can take out of 24 would be 8. So the cube root of 24, I could do the cube root of 8 times the cube root of 3. And then I would have the cube root of a squared times the cube root of a squared times the cube root of a squared. So in the numerator, I would have cube root of 8 is 2. These three make a squared. And then I would have the cube root of 3. That's my numerator. The denominator, the cube root of 125 is 5. So this would be my answer. Next, the fourth root of 80. So fourth root of numbers, so that would be 1 and then 2 to the fourth power is 16. So if I did 80 divided by 16, that gives me 5. So I can do the fourth root of 16 times the fourth root of 5, then times the fourth root of y to the 14th. So that would give us, it goes in there 3 times, so let's do y cubed, fourth root of y cubed times the fourth root of y cubed, so 3, 6, 9, 12, times the fourth root of y squared, so there's my 14. My denominator, 256, 256, I can divide that by, see if we did divide that by 16, this would give us the fourth root of 16 times the fourth root of 16. And this, then we have the fourth roots of z times the fourth root of z times the fourth root of z times the fourth root of z. Now if I simplify this, my numerator, this is 2, 1, 2, 3, 4. This gives me y cubed. So now I have 2y cubed times this fourth root of, and then there I have a 5, and I have a y squared. That's my numerator. My denominator, this is 2, this is 2. 1, 2, 3, 4. This gives me z. So now we have 2 times 2 is 4, and then z. And then I can simplify this, divide a 2 here, divide a 2 here. So my final answer would be y cubed, the fourth root of 5y squared, divided by 2z. Now going back to a previous lesson, we have an even index with an even exponent and an odd exponent here. So technically we need to have an absolute value there, so that would make that always positive. And then we could also do the same thing for our z and the denominator as the absolute value, but we'll just leave it here. If you don't remember to put the absolute value, that's fine. Just know that it should be always a positive number. Next, simplifying each of these expressions. So the cube root of 90, so cube numbers would be 1, 8, 3 cubed is 27. So let's see. There's no cube number I can take out of 90, so it's going to keep that as the cube root of 90. 8 divided by 3 is 2, so I'm going to have an a squared times the cubed root of a squared. And then I'm going to have b cubed divided by 3, so that would be times b. And the denominator, b to the 9th, this would be 9 divided by 3 is b cubed. So my answer on the outside, I would have a squared b times the cubed root of 90 a squared all over b cubed. Now I can simplify this further. I can take 1b away here, take 1 away there, and my final answer would be a squared, the cubed root of 90a squared all over b squared. Next, check this one, write the simplified form. So square root of 9 is 3, x to the second, or not second, 4, and then I'll have a square root of y left over, and take 1y away, that's 12, half of 12 is 6, so it'd be y to the 6th times the square root of y. Divide that by the square root of 25 is 5, square root of x squared is x. And then simplify it, I can take an x away here, take 1 away there. So my final answer would be 3x cubed y to the 6th square root of y all over 5. And because we do have even, odd, this would typically be absolute value. But again, if you forget that, that's fine. I'll understand what you are trying to solve. Next, adding and subtracting radical expressions. Radicals can be added and subtracted in the same manner as monomials when you're adding and subtracting like terms. So radicals are like radical expressions if both the index and the radicand are the same. Although two radicals, such as the square root of 18 and the square root of 32, may not appear to be like radicals, if you simplify each radical, you can see that the square root of 18 is 3 square root of 2, and the square root of 32 is 4 square root of 2. Therefore, you can add 3 and 4 to get 7, and it would be 7 square root of 2. These simplified expressions are like radical expressions and can be combined. So radicals with the same index can be multiplied using the product property of radicals. If the radicals have coefficients before the radical symbol, multiply the coefficients, then multiply the radicands of each expression. So just think, coefficients times coefficients, radicands times radicands. When you multiply, you can multiply with using a couple methods. You can use the FOIL method. You could also use the distributive property. So our first example, simplify this. I'm just adding, I want to break down the radicals to see if I have anything in common. This would be 6 times the square root of 9 times the square root of 5x. Plus this is the square root of 4 times the square root of 3. This would be minus 3 times the square root of 4 times the square root of 5x. When I simplify this, 3 times 6 is 18, square root of 5x plus 2 square root of 3 minus 3 times 2 is 6, square root of 5x. Now, like radicands, I see two of them at the square root of 5x, so I can take the 18 and subtract the 12, subtract the 6, and I get 12 square root of 5x plus 2 square root of 3. And this would be my answer. Next, simplify this one. I have the cube root of negative 8, which will give me a negative 2 plus the cube root of 192. So I think of my cube numbers. Let's see if I can divide 8 out of it. I can. Let's see, another cube number be 27. So 192 divided by 27 does not work. But you did 4 cubed is 64. So let's see, 192 divided by 64 gives you 3. So if we did this cube root of 64 times the cube root of 3x, then minus 4 times the cubed root of 8 times the cube root of 3x. Okay, so this will give us 2 plus cube root of 64 is 4. 4 times 3 is 12. Cube root of 3x minus cube root of 8 is 2. Negative 4 times 2 is negative 8. Cube root of 3x. simplify this. I have a couple of them with cube root of 3x. So I'm going to have 2 plus 4 cube root of 3x. Another one, simplify this one. So square root, so this is a square root of 9, square root of 2x. This would be minus 5 square root of 4 square root of 7 minus 3 times 49 times the square root of 2x plus 3 times the square root of 7x. Now if I combine things, I have 3 square root of 2x minus square root of 4 is 2, so 10 square root of 7 minus 3 times 7 is 21 square root of 2x, and then this one I have plus, so plus 3 square root of 7x. Combine like terms, I have 2x here and 2x here, so 3 minus 21 gives us a negative 18 square root of 2x. Then I have a minus 10 square root of 7 and a plus 3 square root of 7x. Next, simplify this one. So multiplying radicals, so we're going to multiply the coefficients times the coefficients, so that's 12. And then the radicands, so here that will give us, let's break these, so that'll give us the fifth root of a negative 160 x to the 6th, y to the 10th. From there, we can now break them down. Here I have the fifth root of negative 1. Then I have 160. So think of the fifth root. So 2 to the 5th power is 32. So 160 divided by 32 is 5. So I could do the fifth root of 32 times the fifth root of 5. And then I can do 6 divided by 5 is 1. So this would be x times the fifth root of x. And then y to the 10th, fifth root of that would be y to the 2nd. So my final answer, I would have, actually simplify more, I have 12 times the fifth root of 32 is 2. Then I have a y squared, and I have an x. Then I have the fifth root of 5x, and then this fifth root of negative 1. The fifth root of negative 1 is negative 1, so times a negative 1. So this would give me an answer of 12 times 2 is 24 times negative 1 is negative 24 y squared x times the fifth root of 5x. Going on to our next one, multiply the coefficients, that gives us a negative 6. The fourth roots, so we have the fourth root of 5 times the fourth root of 125. 125 times 4 gives us 500. So we have the fourth root of 500. Then we have the fourth root of x to the 5th. And we have the fourth root of y to the 3rd. Now simplify it, the fourth root. So let's see, 500. We can do anything in the fourth root. We can see if we can do the square root of 500. Square root of 500 is not a perfect square, so let's do see the fourth roots of 2 is 16. So if we do 500 divided by 16, does not go in there. Let's do actually it's actually not 500. I was doing 4 times 125. It's actually 5 times 125, which gives us 625. Now if you do the square root of 625, you get 25, and the square root of 25 is 5. So this part is 5. And then here, the fourth root of x to the fifth, which would be x times the fourth root of x. And then here, I can't break that down, so that'll be the fourth root of y cubed. So my final answer is negative 30x times the fourth root of x times y to the third. Next one, simplify this one. So multiply the coefficients, that gives us 15. We're going to multiply that by negative 9 times 27 gives us negative 243. So the fifth root of negative 243, then times the fifth root of x to the seventh, and the fifth root of y to the 10th. Now I got to think the fifth root of a number to get 243. So the fifth root of 3 is 243, so this would be a negative 3. And then I can take 5 x's out of that 7, and that leaves me with the fifth root of x squared. And I can take 10 divided by 5 gives me y squared. So my final answer is negative 45 xy squared times the fifth root of x squared. Next problem. Example 5, use the distributive property to multiply radicals. So the sports pennant has the dimensions shown. Find the area in square inches. So the area of a triangle is base times height divided by 2. So we're told the base is 3 square root of 8 plus 4 times the height, which is 7 square root of 8 plus 6 square root of 3. And we're going to divide all that by 2. So using the distributive property or FOILus, so this will give us 21 times 8 plus 18 square root of 24, and then this will give us plus 28 square root of 8 and plus 24 square root of 3. So if I simplify this, this will give us 168. This can be broken down as square root of 8 times the square root of 3, and the square root of 8 is 2 square root of 2. So 2 square root of 2, this will give us plus 36 square root of 3. Square root of 8 is 2 square root of 2, so this will give us 28 times 2, which is 56 square root of 2. So this one is 6, by the way. And then plus 24 square root of 3. Nothing to combine right there, but all of this we're going to divide by 2. We're going to divide all that by 2. We can now find half of each of those numbers. So the answer would be half of 168 is 64 plus 18 square root of 6 plus 28 square root of 2 plus 12 square root of 3. And that would be our answer there. This would be in square inches. Now you could put all this into your calculator to come up with an exact answer, but an estimated answer, but this would be plenty enough to do. Next, a movie theater screen has the dimensions shown. Write an expression to represent the area of the screen in simplest form, and then find the area of the screen to the nearest square foot. So area of a rectangle is length times width. So I'm going to have 12 square root of 7 plus 6 square root of 5. I'm going to multiply that by 10 square root of 7 minus 2. It distributes. That gives us 120 times 7, because 7 square root of 7 times square root of 7 is 7. Then I have plus 24 square root of 7. Actually, that's a minus. Then distribute here, so we get that's a positive 60 square root of 35 minus 12 square root of 5. So to simplify that, 120 times 7 gives us 840 minus 24 square root of 7 plus 60 square root of 35 minus 12 square root of 5. And that would be our area. Now if we were to find it to the nearest square foot, so this is our expression here. Now it says to the nearest foot, so now I got to put it into my calculator. So 840 minus 24 square root of 7 plus 60 square root of 35 minus 12 square root of 5 gives us roughly 1,105, and this would be square feet. Next, a rectangular pool safety cover has the length of 7 square root of 10 minus 4 feet and a width of 6 square root of 10 plus 8 square root of 5 feet. Which expression represents the area of the pool cover in simplest form? So I need to multiply. So we have 7 square root of 10 minus 4. Multiply that by 6 square root of 10 plus 8 square root of 5. Distribute. This is 420 plus 56 square root of 50 minus 24 square root of 10 minus 32 square root of 5. So to simplify this, this is square root of 25 square root of 2. So 56 times 5 gives us 280. So I have 420 plus 280 square root of 2 minus 24 square root of 10 minus 32 square root of 5. Check any of these. We got 420 cannot be B. 280 square root of 2, so that's not this one. So it could be A or C. Then we have a minus 24 square root of 10. This one's a positive, so it has to be letter C. And the last part for today is looking at rationalizing the denominator. Rationalizing the denominator means if a radical expression contains a radical in the denominator, you can rationalize the denominator to simplify the expression. Recall that rationalizing the denominator, you should multiply the numerator and the denominator by a quantity that has an exact root. So here, if you have a radical in the denominator, just multiply by the radical to get rid of the radical. Binomials of the form a times square root of b plus c times square root of d and a square root of b minus c square root of d, where a, b, c, and d are rational numbers, are called conjugates of each other. Well, think of those as a difference of two squares. So when you have a difference of two squares, you're just squaring the first term, squaring the second term. That will eliminate any radical you have. So our first example here in example 6, the cube root of 250 a to the 6th. So the cube root of 250, got to think, what do I multiply 3 times to get 250? So the cube roots Let's see, 2 cubed is 8, so 250 divided by 8 does not work. 4 cubed is 64, so 250 divided by 64 does not work. 5 cubed is 125, and 250 divided by 125 is 5, so there is 2, so that would work. So we could do the cubed root of 125 times the cubed root of 2 times, this would be a squared. So right now on the top I would have 5a squared cube root of 2, and the denominator I'm just going to have the cube root of 7a. Now I can't break that down, so I need to rationalize it. So I'm going to multiply this by the cube root of 7a. But when I'm doing the cube root of 7a, I'm not just writing it as the cube root of 7a times the cube root of 7a. I'm going to have to multiply that by that 7 times, for a total of 3 down here. That means this will be the cube root of 7a times the cube root of 7a up here. So when I do that, I have 3 groups here, which that will give me 7a. And on top, I would have to multiply those by each other. So let's see, I have, the radicans are not the same. So I would have 5a squared times the cube root of 7 times 7 is 49 times 2 is 98a squared. From this point, I can take an a away up here, take an a down here. So my final answer would be 5a cubed root of 98a squared all over 7. There is no cube root of 98 I can take out of there, and I don't have enough a's to take out. That would be my final answer there. Next, fourth root of 5. So the fourth root of 5, I can't break that down any further. And then I have the fourth root of 4x cubed. Now I have to rationalize the denominator, so I need to have 4 groups total down there. So that'll be the fourth root of 4x cubed times the fourth root of 4x cubed times the fourth root of 4x cubed. Now I just, to know how much I'm multiplying on the bottom, the index here tells you how many groups I need to have down there. So I need to have a total of 4, which I do, which will now give me 4x cubed. And on top, I just multiply by these 4, so, or these 3, so 4x cubed times fourth root of 4x cubed times the fourth root of 4x cubed. This is going to give me the fourth root of 4 times 4 times 4 is 64. 64 times 5 gives us 320 x to the 9th. Then, so now I can simplify the fourth root of 320 x to the 9th over 4x to the 3rd. A fourth root I can take out is 16. So the fourth root of 16 times the fourth root of 20. And then I have, we can take 9 divided by 4 gives us x squared. And I have the fourth root of x left over. This is all over 4x cubed. So right now I would have fourth root of 16 is 2. And then x squared, fourth root of 20x all over 2x cubed. I can take 2 of these x's away, take 2 away there. This is actually a 4 down here, by the way. And then I can divide a 2 here, divide a 2 here. So my final answer would be the fourth root of 20x all over 2x. Next, rationalize the denominator here. So find the square root of 20. So the square root of 20, so that'd be 4 square root of 5b. And on the bottom, so give me square root of, I can have b to the second here, and that would give me 3b here. So I multiply this by the square root of 3b. I now have in the denominator b squared times 3b, which will give me 3b to the third. And in the numerator, I would have 4 times the square root of 15b squared. Square root of b squared is b, so I would have, this would be 4b square root of 15. Simplify, I can take a b away here, take 1 away there. Final answer should be 4 square root of 15 all over 3b squared. Going back to that, just reviewing here, this should not be a 4. That's square root of 4 is 2, so this should be a 2 here. That makes this a 2, means this would be a 2, and our answer would be a 2. So 2 square root of 15 divided by 3b squared. Example 7, using the conjugates to rationalize the denominator. So here we have 4x times 2 square root of 7 minus 5. I have to multiply by the conjugate, which would be 2 square root of 7 plus 5 on the top and bottom. When I do that, I end up with 2 times 2 is 4, square root of 7 times square root of 7 is 7, plus or minus 25. Difference of 2 squares, and on top, this will give us 8x squared root of 7 plus 20x. Simplify this. This will give us, I can take it out, let's take out the 4x again. So that'll give us 2 square root of 7 plus 5 all over 28 minus 25 is 3. So my answer can be written this way as 4x times 2 square root of 7 plus 5 divided by 3, or you could distribute that and write it as 8x squared root of 7 plus 20x all divided by 3. That would also be acceptable. Next, multiply this by the conjugate, so square root of 8 plus square root of 5 in the numerator and the denominator. So this would give us 64, or not 64, 8 minus 5. And over here on top you would have 6y squared square root of 8 plus 6y squared square root of 5. If I simplify that, that will give us square root of 8 is 2 square root of 2. So that would be 12y squared square root of 2 plus 6y squared square root of 5 all over 3. And I can divide a 3 here. Gives me 4. Divide a 3 here, it gives you 2. Divide a 3 here, and gives us 1. So our final answer would give us 4y squared square root of 2 plus 2y squared square root of 5. And our last question, write the simplified form of this. We're going to multiply this by 4 square root of 5 plus 4. that gives us 16 times 5 minus 16. And in the numerator, that gives us 24x squared of 5 plus 24x. We simplify that. We have 16 times 5, which is 8. 16 times 5 gives us 80. Minus 16 gives us 64 all over. And I can simplify this. If I take the 24 out, that leaves me with actually a 24x. That will leave us with square root of 5 plus 1. I can divide out an 8 in the numerator and denominator. That gives me 3. This gives me 8. So my answer could be 3x times the square root of 5 plus 1 all over 8. That would be one way of writing it. Or you could do it as 3x square root of 5 plus 3x divided by 8. Either way, those are both the same answer. That is our lesson on operations with radical expressions.